This is Honors Geometry, section 14.1, and we are talking about perimeter, or perimeter, as they say in the States. Perimeter. This refers to the distance around the edge of a closed figured shape. Perimeter formulas, easy for me to say, are often quite simple because they sum the sides of the polygon. Often does not mean always. For example, in the square, if I wanted to find the perimeter, I would take the length of this side, plus the length of this side, plus the length of this side, plus the length of this side, add them together. Since a square is a rhombus, all the sides are the same length, so the perimeter is just 4 times the length of a side. In a rectangle, if I take this width plus this width, I'll have 2 of those widths, plus this length and this length, I would have 2 of those lengths. So you could think of the formula as 2 times the length plus 2 times the width. I wouldn't get hung up on those formulas. I would just focus on adding up all the sides. If you have a triangle, you want to find the perimeter, you add up the lengths of all the sides. So here we got sides B, C, and D, so the perimeter P is adding those up. If you have a regular polygon, it's just the number of sides times the length of a side. Here's an example of a regular pentagon. Each side's the same, so you can add S together 5 times, or you can do the shortcut, which is 5 times S. Those you're not going to have trouble with. Circle is a little different. A circle, its perimeter is called circumference. And if you were to take and draw a circle, let's say construct a circle using your protractor, compass, using your compass, not a protractor. And you were to measure the diameter, and you were to take a piece of string and measure all the way around here, no matter how big you made your circle. It doesn't matter if it's tiny or huge. If you take the circumference and you divide it by the diameter, you get the same answer every time. That's where this pi comes from. So knowing that circumference is, if you divide it by diameter, you get pi. That's where we get the formula for circumference, which is diameter times pi. And typically, we prefer to speak of circles in terms of its radius instead of diameter. And the diameter is 2 times the radius, so 2r pi. And typically, that ends up being written as 2 pi r. So let's check out an example. Find the missing measurement. We have the circumference is 9 pi, and we want to find the radius. Well, if I use the formula, circumference is 2 pi times r, and I know what the circumference is, 9 pi. I don't know what the radius is. If I then solve the equation by dividing both sides by 2 pi, on the left, the pi's cancel, and I get 9 over 2. On the right, I get r. The units we were using was centimeters, so it's probably better if I write 9½ centimeters. If you prefer, you could write 4.5 centimeters. Number 2, we have the radius that wants us to find the diameter. Well, the diameter is equal to 2 times the radius. I don't know diameter. I do know the radius. So the diameter is 32 centimeters. Number 3, we got the radius is 3 centimeters. Find C with the exact answer. That means you don't need a calculator. Circumference is 2 times pi times r. So that's going to be, we don't know what circumference is. So we got that equal to 2 pi. We know what the radius is. So the circumference is 2 times pi times 3. If you multiply, you can multiply in any order. So that's going to be 6 pi, and the units is centimeters. Check out number 4. We've got the circumference, so we want to find the diameter. Circumference is 2 times pi times r. Circumference is pi. That's going to equal to 2 pi times r. If you divide both sides by 2 pi, To get r by itself, you're going to get r is a half. The diameter is twice that, so the diameter is 2 centimeters. On the flip side, determine the perimeter of the given shapes. Lines that appear to be perpendicular are perpendicular. Well, that's convenient. So, what do we do here? Well, there's different ways to look at this, and let me show you a couple different ways to look at this. One way is simply to say, well, this is 8, so the perimeter consists of an 8, and this is 11, and the distance from here to here we don't know yet, so I'll leave that off. This here is a 2. This here is also a 2 because it has one dash. Now we're missing this blue part and this green part. I think it's reasonable to assume, using the segment addition postulate, that if this whole thing is 11 and you've used 2 from here to here, that this other part has to be 9. So this blue part is going to be a 9. And using similar logic, this green part, this whole thing is 8. And you've used 2 of it from here to here, so this other part has to be 6. So if you add up all those numbers, you're going to get a perimeter of 38. Now let me show you a different way that you could do this that might make more sense or less sense. So I'm going to get rid of all this. This works for perimeter. This does not work for area. If I take that segment and this segment, if I move them, if I slide this over and I slide this one down, those interior segments aren't there anymore. This is just a rectangle. Perimeter-wise, it's the same as a rectangle. So the perimeter of a rectangle, 2 times the length times 2 times the width, so that's 2 times 8 plus 2 times 11, which is 16 plus double deuce, which is 38. These are both centimeters. So don't care how you do it, whatever makes the most sense to you. Number 6. Oh, look at this little fella. We know that the perimeter is going to be 10 for sure, plus a 6 for sure, plus an 18 for sure, plus whatever this last side is. Now, how are we going to figure that out? We're going to figure that out using a triangle. We know so much about triangles. If we drop a perpendicular here, like so, that's going to make this side that's 6, make this also 6. This is a rectangle. This being the shape in here is a rectangle. If this side is 10, then the opposite side down here has to also be 10. If this whole thing is 18, and you've got 10 here, if you subtract 10 from 18, it's going to make this 8. So now we are looking at this right triangle. We know 2 sides, we don't know the third. We could use the Pythagorean theorem, or if you recognize it's Pythagorean triple, 6, 8, 10 makes this third side 10. Third side of the triangle, fourth side of this shape. If you add those little fellows together, you're going to get the perimeter is 44 centimeters. Lastly, number 7, this is a semicircle, which means it's half a circle. I like to focus on the radius instead of the diameter. If you want to focus on the diameter, that's fine. To find the circumference of a circle, it is 2 times pi times r, but you'll notice this is half of a circle. So we're going to use half of this formula. So half the circumference of a circle is just going to be pi times r. And in this case, we're saying that r is 4. So the perimeter of this is 4 times pi centimeters. That concludes these notes. It's not too bad. Some of the problems can get kind of tricky. So please do the homework for this section, that section being 14.1.